Hey there, in this video we're talking about multi-dimensional arrays in C++ programming, and this covers sections 7.8 to 7.9 in the Gaddis textbook. And up until now, working with arrays here in chapter 7, we've been working with one-dimensional arrays all the time, single-dimensional arrays, where you make a block of memory for all your variables, and we think of it as being laid out in just a single line. It has a length, but it doesn't have any other dimension than that. So what we're going to see here is we do have the option of adding additional data to an array that's effectively going to make it act like it has length and also height to it. Or you could actually add depth to it as well. So this provides a way of storing a lot more information, a lot more data in an array. And we do this, sometimes. Let's start with the two-dimensional array to begin with. And this isn't the end of the story, but it probably is the most common thing to do if you're not just using a single-dimensional array. So if you want to declare an array with two dimensions, you do this. Declaring an array, not just one set of square brackets, but two sets of square brackets as you size the two separate dimensions to your array. And what that is doing for us is these two-dimensional arrays are providing a way to structure data like a table. So if I think about a well-formatted table in a book, rows and columns, right, in a grid, that's exactly what this is providing for us. So if you want to, you can think of two-dimensional arrays as rows and columns in a table. You can think of it like X and Y locations in a Cartesian coordinate system. I think of it like mathematical matrices a lot. Again, a grid of numbers like this with two dimensions. So this is how we're going to use it as human programmers and how we're going to think of it. Now, technically, from the computer perspective, it's technically an array of other arrays. I've got an array. What's being contained in the array? Well, actually, other arrays is actually what happens. So we'll probably see that in a couple minutes when we look at one of these things in our debugger. Anyway, so once you've made this, you've actually declared quite a bit of data, quite a number of variable locations, and then you can access those separate variables by putting down the name of the array, two separate sets of square brackets, and indicating what row you want to get at, and also what column you want to get at, and the two square brackets for your subscripts. So that's what that's going to look like. And then when you want to process the data and input it from the user, or print it to the screen, or compute the total, or the average, or the minimum, or the maximum, right? Whatever you're doing, it's probably going to be convenient for your two-dimensional array to be processed using two nested loops. One to iterate over all the rows, and one to iterate over all the columns. So we'll see a couple examples of that, and that'll be very, very convenient to use nested loops like we talked about back in chapter 5 that sync up very, very nicely with multi-dimensional arrays. All right, again, let's just kind of get a visual picture about what we're thinking about. So here we are declaring a two-dimensional array called exams, and now we're going to have two named constants for the two dimensions. I've got rows, which is being set to 4, and I've got cols, which is short for columns, being set to 3. So this is a line right here where we're declaring an array to store integers. It's called exams, and it's got two dimensions. It's got first dimension size 4, and it's got second dimension size 3. So we're going to think about that like this. See, you just made 12 separate variables, is what happened. So we're thinking about having rows, 1, 2, 3, 4 rows, and we're thinking about having 1, 2, 3 columns here. And each of these 12 separate variables is accessed like this. The very first one is exams sub 0 sub 0. Right? And then there's exams sub 0 sub 1 and exams sub 0 sub 2 for each of the items in the first row. And you can count up. The very last one is going to be exams sub 3 sub 2. Remember, if I've got 4 rows, the last index is going to be number 3. And if I have 3 columns, the last index there is going to be number 2. So the very last element in this array here is exams sub 3 sub 2. So these are all individual variables, and you can use any one of them however you want. You can sin into one of them, you can count them, you can assign to them. That's what's happening in this example right here. So if I write exams sub 2 sub 1 equals 86, that takes 86, and it stores it in this location right here, in row number 2, column number 1, and that would get an 86 stored in it. And you can use it in math. You can do whatever. You can pass it into a function if you need to, and do whatever you want. You basically have 12 separate variables at play. Great. And here is our example of this in the book. This program demonstrates a two-dimensional array in program 721. So here, top of the main function, we are declaring our data as usual, and we're making number of divisions 3, number of quarters 4 for the 2 dimensions. So I think what this is intended to replicate is you have a large company. They have a number of divisions around the country, like maybe New York, Chicago, LA. And then you need to track the finances of the company for all 4 quarters of a year. So all 3 divisions have to store information about all 4 quarters, and that's actually 12 pieces of information that need to be recorded. So here on line 10, we're making our array, we're declaring our array. It holds doubles, like we do for money most of the time. The array is called sales, and it's going to have 3 rows to it and 4 columns for the divisions and the quarters. Okay, so that's actually making, again, 12 separate variables. Now, one of the things that's going to happen here is we're going to get the user to input a bunch of data, and then we're going to add it all up, like we said. So finding the total in a big array is pretty common, so that's going to happen here. And we are going to be seeing nested loops in a second. So this div and this quarter are the counters that are going to control the for loops in our nested loops for this. So this program will calculate the total sales of all the company's divisions. And of course, here comes the user input part. The user is going to have to enter the following sales information. And you can see here on line 20 and 22, here's our nested loops. So on 20, you've got a counter for what division you're talking about. And the division counter is going to go 0, 1, and 2, because you only have 3 divisions. And then for each one of those divisions, you're going to get into this for loop on line 22, and you have this quarter counter that's going to go 0, 1, 2, 3 for the 4 quarters. So, it's going to start off, division will be 0, and then for that, you'll have to enter the 0, 1, 2, 3 quarters. And you can see it's going to print out division number 1, quarter number 1. Please enter the amount of money you made. And whatever number gets entered there will get put into sales sub div sub quarter. And the first time through, it's going to be sales sub 0 sub 0. And the next quarter will be sales 0, 1, and then sales 0, 2, sales 0, 3. And you've got all the data for the first division. And then you come back to line 20, and now div becomes 1, and you go through and you get the 1, 2, 3, 4 quarters of data for that division, right? And you keep going like that, and you get data for every single division for every single quarter. So that's the end of the input, I think. Go to the next slide here. So here is the processing part, where we want to add up all those numbers for the entire big company. And so once again, you're going to need nested loops to scan over all the rows and all the quarters. So counting over all the divisions, counting over all the quarters, total sales, which was initialized as 0 on the prior slide, like you need to do for an accumulator like that. So you add in sales 0, 0, and then sales 0, 1, sales 0, 2, and sales 0, 3. And then division gets incremented. Now you're adding in sales 1, 0, sales 1, 1, sales 1, 2, and all the stuff. It all gets added up. And then finally, that's the end of the processing part. And then here comes the output part of this program, where it prints out the total sales for this company are whatever is sitting in total sales. Great. So let's run this in the IDE and make sure we understand what's happening with how the nested loops interact with the multi-dimensional array. Okay, and here's program 721 in the IDE now, our example of using a two-dimensional array. I'm just going to go straight to the debugger and take a look at what's happening in memory. Again, if you ran this program normally, how to compile it there, it's going to run very, very quickly. It's going to look like it finds the total instantaneously once all the data has been entered. But in reality, it's doing a lot of work for us. Put a breakpoint here is what I ought to do. All right. So I'll put a watch on this array. That's really where all the data is going to be sitting, called sales. And I'm going to look very closely in the debug tab here at what that looks like, because I think it's kind of interesting. Okay, so here is sales, right? It's supposed to have 3 rows and 4 quarters. And if we look at it, of course, it's got a bunch of random garbage in it. Not too surprising. But see what it looks like. So it's an array. It's got these curly braces. What is the very first thing in the array? Well, it's another array. See that curly brace right here? That's indicating the start of an array. How many things are in that array? 1, 2, 3, 4. It's a 4-element array. That's actually the first thing in this sales array. And it's a whole bunch of random doubles, of course. It looks like scientific notation, but the important thing is really the first thing in this array is an array with 4 things. And then if we had space to see it, the next thing, there's another array with 4 things. And then there's a third array with 4 things. So when we make what we refer to as a 2-dimensional array, and the human being programmers were thinking about it like this grid, it's really still laid out in memory in a straight line from start to finish. It's just that I've got an array, what's in the array, an array of 4 things, and a second of those, and a third of those, and that's really where the 12 things are laid out. So, computer perspective, an array containing more arrays. But from the human perspective, we think about it like this 2-dimensional idea. That's probably better for our brains, frankly. So what else is here? I have a total sales accumulator that's going to show up a little later. And I have these counters for the nested loops, div and quarter, for the divisions and the quarters. Okay, again, random numbers never begin with. That'll change pretty soon. So we'll start stepping through this, and we'll initialize total sales to 0 right there. Great. And it says this program will calculate the total sales of all the company's divisions for all 4 quarters in a year. And you have to enter the following sales information, of course. Now, again, normally this program wants to look like this, but I have to kind of squeeze it over here to see everything at once. Okay, so into the nested for loop. So division gets created and initialized to 0. Got it? What's going to happen in the body of that loop? Well, you're going to have another for loop. So first of all, quarter gets initialized to 0. And now the prompt is going to say division 1, quarter 1, because of our little +1 trick that we always have. Now I'm going to write in one single number as the user. And I'll keep these numbers small just to make it easy to see. Let's say it's a big company, but I'm just going to type in numbers in thousands. So I'll type in 100 because this first division made $100,000 in its first quarter. Okay, so where is that 100 going to go? It's going to go into sales sub 0 because div and quarter are currently 0. The debugger is a little bit confused right this second, but let's see that happen when I hit enter. Okay, so div and quarter are currently 0, so that 100 got put into the very first thing in the array, which is row 0, column 0, the way that we think about it. So that's the first thing. And now quarter is going to get incremented. And so it'll say, well, for division 1, quarter 2, how much money did you make? And I'll type in 200 this time. There it is. And so where's that going to get stored? It's going to get stored in sales bracket 0 bracket 1 now, which is going to be the second thing in the array. It's going to show up here in place of this 3.18 something something times 10 to the 259th power. It's going to turn to 200. So hit enter over here. And you can see that. There's the 200. And you kind of go on like that. So now quarter just became 2. Right, entering all the information for the first division. And let's say this quarter they made $500,000. Enter. That's the next thing in the array, right? Gets stored there. And now quarter becomes 3, which is the last column, actually, as we're thinking about it. So you need to enter division 1, quarter number 4. And let's say this quarter they made $600,000. Okay. So now you see, we actually have filled out, and now as these numbers get more reasonable, it's easier to see in the debug tab. We actually have filled out all 4 things in the first array of the sales superarray, the sales 2-dimensional array. You got 100, 200, 500, 600. That's all the stuff in the first array, which represents the 4 quarters for division number 1. So at this point, this loop here is about to wrap up because quarter is going to become 4. And when it checks in on is 4 less than 4, that's false. So this loop is at least wrapping up. And you land down on line 28. Okay, print a blank line over here. So the next printing is going to be here. And then that was just the very first iteration of the division counter. So that sent us back to line 20. And now for the first time ever, div is going to get incremented up to 1. Okay, so div is 1. And now you're going to do this quarter loop all over again, as nested loops do. So quarter goes back to 0. And now we're being asked to enter division 2, quarter 1. And let's say this other division, it's smaller. It doesn't make as much money. They made $20,000 that quarter. There we go. Okay, and you can see that's being placed in the first element of the second subarray is where the 20 went. That right there is sales sub 1 sub 0, actually, like the first thing in the second array, 1, 0. So, and you go on like that. So now quarter just became 1 and we're being asked for division 2, quarter 2. Maybe they made $50,000 this quarter. And you can kind of see that's going. So basically, we're filling out this whole array of arrays, this whole 2-dimensional array. So I think I'm going to speed that up here. I'm going to do this full speed. I'll put a breakpoint down here when you get to the processing part and just run this like the program normally does. So this quarter, they made $10,000 and then they made $60,000. Okay, now I got division 3 and the amount of money that they made was 50 and 100 and 200 and 500. Great. Okay, so if we inspect the debug tab here, there you go. And so now you can see the whole array. I got an array. What's in it? Arrays of 4 things each. There's one array with 4 things and a second and a third. And that's exactly the 12 things there. So I kind of like how that's represented in Dev C++ because that's actually how it's really laid out in memory. But we like thinking of it as 2-dimensional arrays. So now you get into this part that wants to compute the total with an accumulator. And again, 2 nested loops. So here we go again. Look at total sales there, starting off at 0 right now. I'll just step through this. So right now, division is 0 and quarter is 0, and you add in the 100 to total sales. And the next step through, now we're going to add in the 200, and I think it'll be 300 for a total. Great. And then you'll add in the 500, and it ought to become 800. There you go. Now we're adding in the 600, so the total will be 1,400. And you keep going like that. So here comes the 20 added in, right there. Here comes 50, here comes 10, here comes 60. We're up to 1540. And now division is about to become 2. There we go. So now we're working on the last division, which is to say the last subarray. And we're going to add in the 50, there we go, the 100, the 200, and finally the 500. And that'll become, I think, 2390 at the end. There we go. Nice. So standard accumulator in a loop. A job we've seen before, right? You ought to be very comfortable with that, at least with a 1-dimensional array, perhaps. That loop's finally wrapping up. And it prints out the total sales for your company are $2,390, according to that. Great. So hopefully that makes sense on what's happening with 2-dimensional arrays. And you really do need these 2 nested loops. 2 nested loops in the input phase, 2 nested loops in the processing phase to add it all up. If I wanted to print out all the numbers in a table, again, I'd need 2 nested loops to get that done. So the nested loops and the multi-dimensional arrays work super nice together. I'm really glad we have both of those at the same time. All right, but that's not the end of the story. So that example there had a 2-dimensional array But you can give arrays more dimensions than that, as a matter of fact. And all you got to do is just start stacking up more square brackets, like this. And you can have 3 dimensions or 4 dimensions or 5 dimensions, or frankly, as many as you need for whatever purpose you're doing. In theory, there's no limit to the number of dimensions that an array can have in C++. The only limit's actually the amount of memory that you have on your computing system. So you will be using up memory pretty rapidly because the total number of variables that you're using is the product, the multiplication of all these dimensions. If I have 3 rows and 4 columns or whatever, I really have 12 variables, right, the multiplication. So if I have 3 dimensions and their size 10 and 20 and 10, so 10 times 20 times 10, that's actually 2,000. I just used up 2,000 variables in my memory system. I'm going to start depleting my memory pretty quickly like that. So kind of be a little bit careful about that. But some purposes might need to do that. We can think of this, if how would you actually use this? You can think of this as pages in a spreadsheet program. I have a bunch of separate pages in the spreadsheet, and they each are a page with rows and columns. So that's actually a total of 3 dimensions, if you think about it. Or it might be multi-dimensional coordinates. If you're doing 3-dimensional calculus or something like that, you might need this, or high-energy physics, perhaps. Admittedly, we're probably not going to literally use 3 or 4 or 5 dimensions in this class, but you ought to know that it's possible. And think about what you do actually to process them. So if I have a 2-dimensional array, I needed 2 nested loops to get all the input or compute the total or something like that. If I have 3 dimensions, what we'll probably need to do is have 3 nested loops, 1 for each dimension. And if I have a 4-dimensional array, I'd need 4 nested loops, and so on and so forth. So hopefully you can kind of visualize what that would look like, even if we're not actually going to literally do it for practice. But now you know that it's possible, and if you ever run into that in somebody else's code, you know what it is. Sometimes people do that. All right, so that is the story of arrays in our starter C++ programming course. So for my students here at the end of Chapter 7, I would recommend that they read book Chapter 7 to get some more details. Now, with one exception, actually, there's the last section in Chapter 7, section 7.12 on vectors, is actually an alternative to arrays. It's a more sophisticated other way of storing lots of data. My students do not have to read that right now. We'll cycle back to that at a later time. Vectors, very interesting, very useful. We don't need it right now. The little secret is vectors are really built on top of arrays. So to understand them, you need to know the basic thing, which is arrays first, definitely. And my students should also test themselves with the review questions in the book at the end of Chapter 7. They'll have a programming challenge on arrays coming up pretty soon from Chapter 7. So they should look at the learning management system, see exactly what that is and when the due date is and stuff like that. And then pretty soon we'll be preparing for our 3rd test. So there is a practice test on the learning management system my students should look at. And this 3rd part of the course, again, has been about how do you handle larger programs. This test is going to be covering Chapter 6 on taking a large program and separating it out into separate functions, and also Chapter 7, having a large amount of data and storing it in an array and processing it as you do. As usual, if someone wants to be a really good programmer and they have extra time, I would highly recommend these additional programming challenges as optional practice. All this stuff is in Chapter 7, getting more practice with arrays, declaring them, passing them into functions. Remember, every single program you're making now is modular with separate functions. So get some practice and get very, very comfortable with creating arrays and using them and passing them into functions for the processing. And these challenges here, 7.3, 7.4, 7.14, would be great for that. Okay, and then my students would get together with me for probably this lab here. We'll do a lab on working with 2-dimensional arrays. So there's this starter file, price.cpp, and the goal here is to let the user construct a table of numbers on the screen. So basically just print a bunch of numbers in a grid like this. And the interesting thing is they're calling it price data, but it doesn't really matter. The interesting thing is that it can be sized to however big the user needs. And what they do there is they use a partially filled two-dimensional array. And if you look at that code, they may just make one really big two-dimensional array and then ask the user, how many rows do you need to use and how many columns do you need to use? And then in practice, you actually just fill in data for the start of the array, so the user gets to make it a bit smaller or bigger depending on how much data they have. And then they should enter all the data, and it should get printed on the screen in a very nicely formatted grid with the columns all aligned and sized up. So I'm sure we want to use the set width function for that kind of thing. If you remember back in chapter 3, if you're aligning columns in a table, and that's exactly what we're doing here. So it's getting some good practice about prior things that we've talked about in the course here. So that's it. So that's the part 3 of the course on functions and arrays. Super important, super useful. And boy, our programs look a lot different than they used to, but now we are a little bit more comfortable with what professional programs look like when they get bigger like this. Now, when we come back, I have another part of my beginner course that I teach that I call part 4, where to a large extent we go back and we fill in some stuff we didn't have time for before. So that includes stuff like file handling, saving stuff on the hard drive, which was the last section in chapter 5. We'll talk about vectors, which is the last thing in chapter 7, which is an alternative way of storing lots of data, which is really just an array in disguise, frankly. And then we'll also talk about an alternative way of getting information into your program by command line arguments on the interface. And that actually is going to be interesting because it explains what the parameters are coming into the main function. If you've ever seen that, like in Dev C++, it shows you to that normally. And sometimes I have students asking, what are the parameters coming into the main function? And we get to finally answer that near the end of our course. So hopefully that sounds interesting, and I'll see you then for that.